Okay, hello, hi. So my name is Francis Choi. I work with the Helmet Lab at Northeastern University up in Boston. And our lab focuses on identifying and forecasting microhabitats at the Rocky Shore. More specifically, thermal microrefugias at the Rocky Shore at a scale that is relevant to our organisms. And so that's important because here's a mussel bed, and even at the scale, you can see there are temperature ranges that are good for mussels to live in, and there's temperature ranges that are too warm for mussels to live in. And body temperature really drives most of these organisms if they're going to survive or not survive. And so microhabitats or microrefugias has been a really growing studies that look at really just the resiliency of the ecosystem. So after an event after a stressful event has occurred, can microhabitat be a source that repopulates that ecosystem and maintain it at a stable state instead of shifting it to a different stable state? And so we do this using different types of tools. For example, we want to measure elevations that is at a scale that's relevant to fluid mussels. So we use photogrammetry to recreate 3D models of rocky shores. And we're able to, for example, for here, it's a 100 meter by 50 meter rocky shore system. We can recreate this in a digital elevation model at a scale of 2 centimeters per pixel. And so incorporating the elevation data with a heat budget model that estimates body temperature of an organism using environmental data, you can see spatially and temporally start to identify these temperature ranges that are good and bad for mussels to live in. And so that's just part of the first part of identifying microrefugias. The physiology is really important as well. So we adopt a thermal performance curve that is a relationship between temperature and performance. And performance could be respiration, could be heartbeat, could be food assimilation. And so we can incorporate this to our temperature maps. And you can identify on a curve different areas that are good and bad for our organism. For example, the blue here, optimal, is where our thermal refugia or microrefugia could exist. And so when you incorporate this into a map, you can see, and hopefully you can kind of see, the blue areas and start to identify where the microrefugias could occur. And again, it changes spatially and temporally as well. And so we looked at just single species. You can layer on top different species to try to start looking at community structures in a very simple way. And so example here, you have a blue organism with optimal 28 degrees Celsius. And then you have a purple organism of 25 degrees Celsius. And the purple organism is maybe computationally more dominant than the blue. You can kind of, not really see it there, but you can kind of describe where the blue habitats are. They're bounded by the temperature range and also bounded by its competition dominant neighbors. And so these maps are really good to just visualize where microhabitats are, but it's hard to quantify them. And so we're taking a page out of mechanical engineers where they describe topography and complexity through RQ. And so the greater the RQ is, the more complex the surface is. So why not adopt it to temperature? So RQT could be the greater the RQT is, the greater the temperature variation you're going to find at that site. And so with frequency distribution graphs, you can kind of identify what's the best temperature for these species are at each time of this location. And why not adopt it to performance as well, which is where the microrefugia exists. And you can see that the greater RQP is, the greater there's different types of microhabitats that exist. And so with the frequency distribution, you'll be able to identify where the microrefugias are compared to where the microhabitats are. So I think that was really quick, but we have a paper coming out in conservation physiology that goes in depth to some of these models and able to kind of forecast where these refugias are to repopulate after stressful events. So thank you guys.